Hi everyone, today in Integrated Math 2, we're going to go over Chapter 10, Lesson 4. Here are the objectives. Make sure you write them down in your notes. Alright, so the first thing that we're going to go over today is trigonometric ratios. So we have a sine ratio, cosine ratio, and a tangent ratio. Those are our three that we'll be looking into today. When we're trying to find something known as sine theta, that is equal to the opposite divided by the hypotenuse. For our cosine ratio, that is cosine theta, is equal to adjacent divided by hypotenuse. When we're trying to find tangent ratio, that's tangent theta, which is equal to opposite over adjacent. So when we're talking about the opposite side, so in this case, this is going to be beta for each of our reference points, because this can change depending on what angle you're looking at it. So when we're first of all talking about opposite, that is a side opposite the angle, or you can also think about it as a side the angle is looking at. So in this case, it's directly across. So this would be our opposite angle here, and this is our opposite angle here. Then when we're talking about hypotenuse, that is always going to be the side opposite the right angle, directly across from it. In this case, there's our hypotenuse as well. I'll just label it as H. The last term we want to go over is adjacent. So adjacent is a side that is touching the angle that is not the hypotenuse. So in this case, this would be our adjacent angle here. So a way to remember all these different ratios without trying to remember opposite hypotenuse, adjacent hypotenuse, is to remember this little acronym here. SOH. So sine opposite divided by hypotenuse, SOH. Cosine equals adjacent divided by hypotenuse, cosine adjacent hypotenuse. Tangent, opposite over adjacent, just like this one is as well. Tangent, opposite, adjacent. Alright, so now we're going to go ahead and write a trigonometric ratio for each of our different terms. So I'm going to write our little acronym up here. So, TOA. Just write your little acronym up here to help you out. So for each of these, we're going to start by finding our alphas. So sine of alpha is equal to our opposite, which is 3, divided by our hypotenuse, which has to be 5. And you can divide that if you wanted to get an actual number as a decimal. Let's say we want to find cosine alpha. That says adjacent, so that'd be 4 divided by the hypotenuse, which is 5. Then let's say tangent alpha, opposite, 3 divided by the adjacent, which is 4. So as you can see here, each of these gives us a different fraction, so you can't just rely on one of them to say you're going to find sine. It's not the same between sine, cosine, and tangent. They're all different reference points that we're talking about. Now let's do the same thing but for beta, so you can see how they switch up, how they change. So sine beta, opposite, now it's 4, and hypotenuse, which is 5 still. Then we have cosine beta, which is adjacent 3 divided by the hypotenuse, which has to be 5. Then let's do tangent beta, opposite 4 divided by adjacent, which has to be 3. And once again, as you see, these are all very different from each other for the fractions. Now let's say instead of trying to solve for the alpha or beta, let's say you're just trying to solve for a side. So in this case, we're trying to solve for x. Alright, so I'm going to write my little acronym up top to help us out. So, TOA. Let's identify what we have. Remember, we're referencing this angle here. Instead of alpha and beta, this time they tell us it's the degree of 37. So x, we know, is the hypotenuse. Then we have 27, has to be the adjacent. So if we have the hypotenuse and adjacent, we know we're going to be dealing with cosine. Adjacent and hypotenuse. So I'm going to say cosine this time, 37 degrees is equal to the adjacent, which is 27, divided by the hypotenuse, which is x. And now I want to solve for these, but the problem is I want to solve for x, and the x is on the bottom. So I'm going to multiply both sides by x. And now I want the x alone. If you want to box it, you can do that. Imaginary multiplication symbol there, which means in order to undo it, you must divide, do the opposite. Cosine 37 degrees. And that becomes 1, not 0. X is equal to 27 divided by cosine 37 degrees. And then when you put that in the calculator, you're going to get the x right around 33.8 degrees. All right, then we have inverse trigonometric ratios. So we have one for each sine, cosine, and tangent. If sine of A is equal to x, then we have sine inverse of x equal to the measurement of angle A. If cosine A is equal to x, then cosine inverse of x is equal to the measurement of angle A. If tangent A is equal to x, then tangent inverse of x is equal to the measurement of angle A. So let's try a problem with that so you can see how that works. Okay, so the first thing we want to do in solving for this angle is to see what we can use for this one. So we have TOA. Let's see what we can actually use. So we're trying to find this angle. In this case, it's beta. We have the one that's opposite. So 35 is equal to opposite. And then we have 47, which is our adjacent angle. So in this case, we have opposite and adjacent. And then because of that, we know we're going to use tangent. So now I can say the tangent of beta is equal to 35 over 47. Think about this one as you want to solve for the variable b, because we don't know how many degrees it is. So what we need to do is to find the inverse of tangent. If you do it to one side, you must do it to the other side as well. So tangent inverse. That goes away. We know that beta, therefore, must be equal to, and then we'll put this in the calculator, and we'll get that it's right around 36.7 degrees. And there we go.